Hello everyone, among four parts of pneumoconiosis, today I am going to teach you about the part 1 of pneumoconiosis. So what do you mean by pneumoconiosis? It's a group of chronic diffuse interstitial lung disease. It's a diffuse interstitial lung response that is caused by inhalation of aerosols, particularly like that of mineral dust, then organic dust, then chemical fumes and vapor, toxic vapors. So all these four can lead to diffuse interstitial lung disease, which is known by the name pneumoconiosis. So let's understand the pathogenesis of pneumoconiosis. All exposed person doesn't develop pneumoconiosis. Suppose you have the mineral dust exposure, you have the organic dust exposure, then all individual doesn't develop pneumoconiosis. There are six important factors which is responsible for the development of pneumoconiosis. The first factor is genetic factor. The first one is genetic factor. The second factor that can lead to pneumoconiosis development is depend upon amount of dust retained in the lung and the airway. So amount of dust retained in the lung and airway is also responsible for the development of pneumoconiosis to decide whether pneumoconiosis is developed or not. And the amount of dust retained in the lung which ultimately depend upon three factors: the concentration of dust in the air, then duration of exposure, and host defense. So these three factors will decide how much amount of dust will retain in the lung. Third factor responsible for pneumoconiosis is the size of particle. If the particle size is small, especially 1 to 5 micrometer, then such small particle can reach the terminal airway and the air sacs. They can reach up to the alveoli, terminal airway. They can reach up to the terminal airway, and that's why it is a more dangerous. If the size of particle is very small, then it's very dangerous. It can reach to the alveoli. The fourth factor is solubility of a particle or solubility of dust. So if the particle is small, then it is a soluble in the pulmonary fluid, which are more soluble. The small particles are soluble in the pulmonary fluid, and that's why they can produce a acute lung injury as compared to chronic injury. They will produce more acute lung injury. All right, so patient can undergo ARDS in that condition. All right, now if the particle size is large, then it's not a soluble. The large particles are not soluble, and so they can persist in the lung for years. They can persist in the lung for many years, and so they ultimately lead to development of pneumoconiosis. All right, especially silicosis can be developed. The fifth factor for the development of pneumoconiosis is inflammasome activation. Now, what do you mean by inflammasome activation? So, friends, whenever there is a particle in the lung, the macrophage will do phagocytosis of that particular mineral dust. Certain particles will be ingested by macrophage for doing the phagocytosis. So, by doing the phagocytosis, the macrophage will initiate a immune response. They will initiate an immune response, and that's why they will amplify a local inflammation intensity and duration. They will amplify the local inflammation intensity and duration. That is by initiating the immune response. So there will be more inflammation because of phagocytosis. So that is the inflammasome activation. Sixth important factor is additional other irritant factors. If you have the additional exposure of irritants apart from mineral dust, like that of smoking, the smoking will act as a additive to worsen the effect of all inhaled mineral dust. Smoking can worsen the effect of all exposed mineral dust, so they can favor the pneumoconiosis development. All right. Now let's see the examples or classification of pneumoconiosis. So first we will begin with mineral dust category. The first example of mineral dust agents is coal dust. The coal exposure can lead to development of disease like that of macules, anthracosis and fibrosis. And the exposure or occupation related to the coal dust exposure is coal mining and especially hard coal. All right. The second example is silica, which can lead to development of silicosis. The disease develop is silicosis, and the silica exposure can occur because of metal casting work, you know, sandblasting, then hard rock mining, sandblasting, then hard rock mining, and stone cutting. All these can lead to silica exposure and so development of silicosis. All right. Third example of mineral dust category is asbestos exposure. It can lead to development of pleural plaque, mesothelioma, then asbestosis, then carcinoma of the lung, the cancer of larynx, cancer of stomach, colon, all that can be developed because of asbestos exposure. Now, how asbestos exposure occurs? So it can be because of mining, it can be because of manufacturing, mining, milling, then in the fabrication industries, those who are involved in fabrication work, then installation and removal of insulation, the installation and removal of insulation, all that can lead to exposure to the asbestos. All right. The fourth one is beryllium. Now the beryllium exposure can lead to development of berylliosis or granulomatosis or lung carcinoma. It can lead to development of berylliosis, granulomatosis or lung carcinoma. And exposure is by mining industries and in the manufacturing. All right. The fifth mineral agent is iron oxide, which can lead to development of siderosis, and exposure is by the welding work. The sixth example is barium sulfate exposure. It can lead to development of barytosis, and the exposure is by the mining. All right. The seventh example of mineral dust category is tin oxide, which can lead to development of stenosis, and exposure is by the mining. So these all are the example of mineral dust category lead to development of pneumoconiosis. Now let's see the organic dust induced hypersensitivity pneumonitis. So let's see the example of organic dust induced pneumoconiosis. So the first example is moldy hay. It can lead to development of farmer's lung, and obviously the exposure is by doing the farming. The second example is bagasse. It can lead to development of bagasosis, and exposure is by manufacturing or by wallboard or paper. So in that way bagasosis can develop. The third example of organic dust induced hypersensitivity pneumonitis is bird dropping. It can lead to development of bird breeder's lung. The disease develop is bird breeder's lung, and the bird breeder's lung is developed because of bird handling. Those who are involved in bird handling can develop this particular disease. All right. Now let's see the organic dust that can lead to development of asthma like that of hypersensitivity type 1. So the first exposure is cotton, which can lead to development of bicyanosis. And the exposure can be by textiling or manufacturing. So textile manufacturing is put you at the risk of development of bicyanosis. Then red cedar dust can lead to development of asthma, and that is seen in carpentry or lumbering. So this is the example of organic dust induced asthma. Now chemical fumes and vapor. Fourth category of pneumoconiosis is chemical fume and vapor exposure. So the example of that include nitrous oxide, then sulfur dioxide, then ammonia, then benzene exposure, then insecticides, right? All that are example of chemical fumes and vapor, and that can lead to development of bronchitis, asthma, like that of various respiratory disease, right? They can lead to development of pulmonary edema, then acute respiratory distress syndrome. They can lead to development of mucosal injury of respiratory tract, and sometimes fulminant poisoning can lead to severe degree of respiratory distress. So it can lead to variety of respiratory disease, and exposure is by occupational or sometime accidental exposure. Mainly those who are working in that particular industry can develop these pneumoconiosis. Thanks for watching, and I will be right back with a new video. So we will discuss the part 2 in our next lecture of pneumoconiosis. So these are my references.